Hello, my name is Chris Schiebel. I am the project manager for HHBS Engineering, and we are here today to give our final presentation on the Brooks subdivision development. First off, I'd like to introduce our team members. We have Andrew, who's the transportation lead, Jabril, who's the environmental lead, and Jacob, who's the water resource lead. So our project description, we were tasked with developing a large plot of land for residential subdivision use, as well as other things such as the design of a two-story visitor center, roadways, pedestrian access and parking lots, the design of a collection system, lift station, and bank stabilization, as well as the design of stormwater management for runoff. So jumping right into the structure section, my scope was to design a two-story visitor center, which was supposed to be approximately 40,000 square feet with a 1,200 square foot covered outdoor attached space. So the project will be located on the northeast side of the project limit. This is to allow the use of the subdivision right next door to have access to the building, as well as the subdivision that is developing. So the load summary tables are included in the slide. This is the live load table, which is just the live loads that the building may encounter, as well as the different weather loads that were pulled from the CEE hazard tool. So this is the general floor layout. During my first presentation, I went through the different floor layouts for all three alternatives. However, because the rooms don't change in location, the only thing that changes is the span of the different columns, I felt that to save on time, I would just show you the general floor plan that will be applied through all three layouts. So my first alternative is a two-story 135 foot by 150 foot structure. It will be composed of structural steel and will be approximately 40,500 square feet. It will have the 40 foot by 30 foot covered outdoor attached space, which will also be composed of structural steel. This outdoor space through all three alternatives will be used as an entryway for the visitor center, as a covered entryway. When doing the cost calculations, RS means gave our total for alternative one to be $6.1 million, and with the 30% contingency, this cost came out to be about $8 million. This is the structural member layout for alternative one. The thing that changes for this is the spacing up here. This one has a 35 foot span. In the last part, this is 30 foot all the way down, and it has the first floor has the outdoor space. This is alternative two. It is a two-story 130 foot by 150 foot steel structure. It is composed of reinforced concrete, and it is approximately 39,000 square feet. It's got the 30 foot by 40 foot covered outdoor attached space, which is also composed of reinforced concrete. RS means came out to be about $6.8 million. With the 30% contingency, it's about, I would say, $8 to $9 million. This is the structural member layout for the reinforced concrete option. This changes to 30 foot over here, otherwise it stays the same all the way down, and it has the covered outdoor attached space. So alternative three is a two-story 150 foot by 150 foot structure. It is composed of structural steel, and it comes out to be about 45,000 square feet. It's got the 40 foot by 30 foot covered outdoor space, which is also composed of structural steel. This cost came out to be $6.8 million, and with the contingency, it's about $8.8 million. This is the floor layout. The thing that changes for this one is it's 30 feet all the way across and all the way down, and it's got the outdoor space attached to it for the first floor. So going forward to determine my preferred alternative, I use the selection matrix listed below, focusing on cost, environmental impact, workability, and aesthetics. When I filled out this cost matrix, it came out to be alternative one had the highest total, which would be the preferred alternative. Cost was put as the most important, followed by environmental impacts, workability, and aesthetics. So the selected alternative is alternative one, which is a 130 foot by 150 foot structure with the 40 foot by 30 foot covered outdoor attached space. It is composed of structural steel. It is chosen because it's the least expensive alternative, as well as it being composed of structural steel, which is really great in tension, and it is a ductile material. I'd like to turn it over to Andrew.
Hello. So I'm going to begin by reviewing my scope. I've been tasked with the design of two new roadways, Bell Park Road and Old Oak Drive. In addition, I'm responsible for pedestrian accessibility throughout the site, and that will be achieved through the preservation of the existing path on the south side of Bell Park Road and the addition of a new one on the north side of Bell Park Road. Finally, I'm responsible for the design of the parking lot for the proposed building on site. As of now, I have completed all my tasks through phase one of this project, and that includes the design, evaluation, and selection of my alternatives, the development of a construction cost estimate, which will be reviewed further on in this presentation, and creation of preliminary design drafts for each of the transportation features of this project. In order to properly assess the alternatives, I've created a rubric featuring various criteria. These criteria each have their own weight multipliers, and each alternative will receive a grade between 1 and 5, and that grade will be multiplied by the respective multiplier. These will be summed, and each alternative will receive a total grade. So now let's talk about some alternatives. Starting out with the horizontal alignments, we have the existing path route and the higher elevation route. And here are the grades that I've assigned to these respective alternatives. I ended up selecting the existing path route, and the characteristics that helped me decide this were the cost effectiveness. Less construction will be needed on that pedestrian path, as it just follows the pedestrian path. Practicality, it just makes sense to follow the existing path that already exists on the site rather than to stray away from it. Also safety, so this alternative features larger radii across the horizontal curves, which allows for larger sight distances for drivers when compared to the other alternative. So here's the CAD drawing that I created for this alternative. And now we'll talk about some intersection alternatives. We have the roundabout, signalized, and stop control intersections. Here are the grades that I've assigned to these alternatives. And I ended up selecting the stop control intersection with Old Oak Drive stopping for Vale Park Road. What my rationale for this is cost effectiveness and maintenance, as a stop controlled intersection would require a lot less maintenance and would likely be more cost effective when compared to your roundabout and your signalized intersections. And here's the hand-drawn draft that I've created for the stop controlled intersection. Now we'll talk about parking lot design. So the two alternatives that I have are perpendicular spaces and angled spaces. And here are the grades that I've assigned to these alternatives. I've selected perpendicular spaces, and the reason being safety first off. A perpendicular space parking lot allows for two-way travel, while a angled parking lot requires one-way travel, and this avoids driver confusion. Also, we have land usage. The perpendicular parking lot that I developed is 58,000 square feet, while the angled space parking lot is 74,000 square feet. Finally, in a perpendicular parking lot, drivers can pull through the spaces or back into spaces, which is a great feature to have. So next we'll talk about some alternatives that I've developed since we've last spoken. Starting out with drainage design, we have either curb and gutter or a drainage ditch. I ended up selecting the drainage ditch system, and this came down to land usage, as a curb and gutter system takes up a lot less space along the roadway when you compare that to a drainage ditch. Also, aesthetics took a role in this. Most likely homeowners would prefer to have a curb and gutter system in their front yard than a big drainage ditch, especially if we were to have houses built along the roadways that we are designing right now. So here are the cross sections that I've developed for each roadway. You can see they feature the curb and gutter. So lastly, I'm going to talk about the material selection. So I went with asphalt over concrete. What mainly went into this selection is where we're working, where we're designing these roadways. We're working in a residential neighborhood area. We're not. If you look on a map, basically all the roadways in the area are asphalt roads. Asphalt may be deemed as less durable than a concrete roadway, but we're not designing a major arterial, a major expressway. This is a residential area. Also, it won't be expecting high levels of truck traffic compared to larger roadways. Finally, noise. Asphalt is softer. It's better at absorbing the sound waves, and less noise will be generated when compared to a concrete road, which is nice in a residential area. So now we'll talk about construction cost estimates. I used the NDOT unit price summary to find the unit price of each material, and I multiplied that by the quantity of material expected, and here are the estimates for each material, and I broke down the costs of each roadway, and I summed those costs up, and I added a 30% contingency to account for any costs that I may have not gotten to in the preliminary design phase, and I got a cost of just over $2 million. Now I'll hand it off to our environmental engineer.
Hello everyone, my name is Jabril Hoskins and I'm the environmental engineer here at HHBS Engineering. To quickly recap what my scope actually entails, so I am tasked with designing a wastewater collection system along with a lift station and a bank stabilization system. All three of these tasks will be in compliance with the city of Valparaiso, Porter County, Indiana, as well as the federal government. To summarize what my design alternatives were, I came up with 3 alternatives per task. For the collection system, I decided to look at PVC, DIP, and HDPE for the piping material. For the lift station, I looked at 3 elevation points based off of the site's topography. And lastly, for the bank stabilization system, I looked at a vegetated rock gabion baskets, live crib wall, as well as an Ajax hard armor system. This slide here details the point scale that I applied to each of the design alternatives, with 5 being highly favorable, 3 being favorable, and then 1 being not favorable. The alternative that had the most points at the end ended up being the selected alternative. And then the design parameters differ per alternative, so I apply percentages, and the higher the percentage, the more important that I feel like it is for design criteria, and vice versa. Here, as you all can see, this is the collection system analysis. For the pipe material, I looked at the advantages, disadvantages, velocity range, and total cost. As you can see, PVC ended up being the highest point total, therefore I chose PVC as the pipe material for the collection system. So advantages to PVC include that it's cost-effective, resistance to rust and corrosion. It also complies with the Valparaiso construction standards, and the velocity range within the pipe is expected to be 6 to 10 feet per second, and the total cost for that ended up being around $86,000. Next, for the lift station, I looked at 3 elevation points, as you all can see detailed at the bottom left-hand corner of the screen. I looked at the elevation, the distance that it was from the road alignments and from Beauty Creek. And low point 3 ended up being the highest point total, therefore low point 3 was selected based off of the design parameters. And the other thing is that it is furthest from the creek, and as Dana mentioned in her presentation, the lift station needs to be in an area that is very accessible. Therefore, low point 3, as you all can see, in comparison to low point 1 and 2, is furthest from the creek as well as the road alignments. Lastly, for bank stabilization analysis, I looked at the aesthetics, effectiveness, feasibility, lifespan, total cost. Now, based off of this design matrix, the highest point total ended up being the vegetated rock gabion baskets. Therefore, I decided to select the rock gabion baskets as the preferred alternative. The one thing to note is that the aesthetics for this did not necessarily beat out the live crib wall, but I felt like because it was high efficiency and total cost coming in around $18,000, that would be the best alternative for that. Now to recap, the alternatives that I chose. For the collection system, the piping material will be PVC. For lift station, I'm using low point 3 at an elevation of 760 feet. And then for the bank stabilization system, I'm using vegetated rock gabion baskets. On the right-hand side of the screen, you all can see the approximate cost estimates per task. One thing to note is that these costs are actually higher than what I showed on the screen because they incorporate things. So like for the collection system, it includes the manholes, the trenching, the excavation. For the lift station, that price is pretty high because it includes the actual lift station itself. And then the base stabilization cost was really just the cost for the rock gabion baskets. Similar to what Andrew did, a total cost applied a 30% contingency fee, and that came out to be just shy of $1 million.
Hello, Jacob. I'm the lead for the Water Resource Engineering Department for HHBS Engineering, and I would like to quickly review my scope description with you. The Water Resource Department is required to filter and filtrate at least 1 inch of runoff from all impervious surfaces, reduce the total solid by 80% and the metal load by 65%, allow adequate storage for flood control, and that's based off of the 100-year storm, and then comply with all City of Valparaiso regulations. When we met last, I gave an outline of different management practices that I was considering using to develop alternative schematics. I will quickly go through the alternative schematics that I have developed and my selection criteria for selecting them. So the first alternative, it uses, on the development site here on the bottom, it uses rain gardens surrounded by filter strips to treat the water as it flows into a dry pond. Along the roadway, it uses swales to direct the, it uses bioswales to direct the water, treat it, and then it flows into a dry pond on either end of the roadway. You can see down in the corners there. For alternative 2, The configuration for the development building site stays the same. However, I have added along the roadway tree boxes to treat the water as it runs into rain gardens and a wet pond. Rain gardens surrounded by filter strips and a wet pond along Bell Park Road, and a dry pond along South Old Oak Drive. For the next alternative, I decided to stick with the same layout for the roadway from alternative 1. However, I introduced bioswales into the development portion site to add additional treatment to the water. And then finally, for the 4th alternative, this uses the development layout from alternative 3 along with the roadway layout from alternative 2 to add another configuration for evaluation. To evaluate these alternatives, I first did a cost estimate. This was gathered by researching industry averages for construction and maintenance costs of the different management practices that I decided to use. And I calculated a capital cost, a 25-year operation and maintenance cost, and then added a 30% contingency for any unaccounted costs that might not have been considered in the preliminary design. I used an evaluation matrix to evaluate the 4 alternatives. I placed efficiency as my highest weight, and also evaluated based off of functionality, aesthetics, cost effectiveness, and regulatory compliance. I turned out with alternative 2 as my preferred option, and that also works easily with the curb and gutter system that Andrew is designing. The tree boxes easily integrate with that and save space and help with filtering the water. With that, I will turn it over to Grace.
So this is our total construction cost throughout all 4 of our different disciplines. This is the costs that were pulled from the alternatives that were selected. The overall total construction cost of the project is $12.2 million as of right now. I'd like to open it up for any questions. Any questions?
Go ahead.
I have a question for you. In your still structural layout,
Which one?
the one that you're showing the brace frames,
Yeah.
yeah. So in one direction you're using brace frames, oh yeah, that one.
Yeah.
I suppose for lateral forces. What is the lateral force resisting system in the perpendicular direction?
You mean like here?
Yeah, so this is, I assume it's west-east.
Yeah.
You're using brace frame, but you should also have like,
It will be added. This is just a preliminary design of just like where I might place the columns and the beams and the girders and the different frames. I definitely plan on adding the brace frames here as well as here and here.
so both side brace frame.
Yeah, both sides, right. This is just preliminary design, so moving forward, I would definitely look more into where's the appropriate place to place the brace frames and where they're gonna be most efficient.
Thank you.
Jabril. Excuse me. On your slide, I don't know which one it was where you were talking about advantages of the preferred alternative. Oh. No, earlier than that. Yikes.
For real.
Somewhere you said that PVC was selected. It's after that. Go on what slowly. No. One more. Was that one more? Yeah. Yeah. Go ahead.
This,
No, keep going.
this,
There. That's it. explain to me again, you have collection system PVC.
Yeah.
And you said something about because it meets standards.
Correct.
Isn't there anything else that would meet these standards?
So I also looked at with HDPE, because that is another plastic material, but I went specifically onto the Operator Utilities website, and they have an entire manual detailing how to use PVC for sewer installation. So I chose that because PVC is also a common material that gets used for high networks and collection.
It's a picky question, I know, but when you said, I select the PVC because it met the standards, well, so do other things.
Yeah, I should explain that earlier.
Okay, good, thanks.
So Jacob, could you recap your preferred alternative? It was what, alternative 4?
Yeah. My bad.
Oh, I just didn't get a good look at it the
Oh.
first time. So you get a tree box, a dry pond, a wet pond, rain gardens, and then in the building site, more rain gardens, a dry pond, right? So,
I forgot to add into the legend, the green there are bioswales
Okay.
to convey
Okay.
water and also treat it.
okay. And then you mentioned that your scope was to remove or retain metals, right,
Yeah.
and solids, right?
Solids.
So do you think, how's that gonna meet it? What's gonna contribute most,
So-
or how's that gonna be met?
The rain gardens and the filter strips will help with the solids and the metals more specifically. And then they also, with this sedimentation in the dry pond, that'll also help with the solids. And
Okay.
everything like that. And then there's other pollutants in water, but those are not a part of the scope. So I'm mainly focusing on the pollutant, or the solids and metals.
Okay. So I'll ask you the same question I asked Chris. So do you have any concerns with the rain gardens not doing so well with other pollutants, even though they're not the targeted ones?
No, it's outside of my scope, so.
Okay.
Was your preferred alternative 2 or 4?
2,
Okay.
sorry.
Oh,
Yeah.
Oh, it
that's-
was 2?
Yeah.
Can you go to, what's the difference then between,
2, there's no
Bioswale?
bioswales on the development site there for 2.
okay.
Yeah.
I might ask you to put bioswales in for design work, but, okay.
I have a question for your environmental engineer. From where or whom did you get your unit prices for your pipe?
Our things.
Okay. You didn't get the friends or family discount from the mayor of Pipe City?
It's not in there, Pipe City.
It's right there.
Really?
They give you a good deal.
Yeah, no, those prices actually came from RS Means. It included the overhead and profit costs, and a more detailed cost breakdown will be included in the too.
Thank you.
Thank you.
Jake, where did you get your cost estimates? And because you had operating and maintenance costs in there, didn't you?
Yeah. I used multiple different sources to find those. I have them listed, sourced in my report. But,
Okay.
yeah.
Any other questions? Okay,